All right, so we are starting lesson 5-4, and in lesson 5-4, we are going to be solving system of equations by elimination. And so far, I'm in the workbook, page 287. So you don't need to write this down. I just wanted to kind of talk over this. So far, we have solved a system of equations by graphing. So we had two equations. The work behind it was that you had to get both in y equals mx plus b, right? Then you had to graph both. And then you had to say whether or not they intersected at one point, or if they were parallel, which meant no solution, or if they were the exact same line, which meant infinitely many solutions, okay? And then we solved, by substitution. And that's the method that we've been working on probably for the last 4 days or so. And in substitution, that was those 7 steps that we went through in, I believe it was 5-3. Is that substitution? Yeah. So in 5-3, we went through all the substitution steps. And when you solve by substitution, right, you've got one equation. We'll just put 2x plus 3y equals 4, and then we'll do x equals 2y. Okay, so in a substitution problem, we would substitute the clue from one equation into, so if this is a clue about x, we'd find the x over here, and we would substitute that 2y, so we would say 2 times 2y, not equals, sorry, plus 3y equals 4, and then we would take 2 times 2y, which is 4y, plus 3y equals 4, and then we would go ahead and combine like terms. Actually, just to make this come out even, I was making this up on the fly. Let's change that to a 7. There we go. Okay, and then we combine this and we get 4y plus 3y is 7y, and then we would divide by 7, and we get y equals 1. Then we would come back up here to this equation, x equals 2y, and in place of the y, we now know that y equals 1, so we would substitute that in, and we would get x equals 2 times 1 is 2. So the solution in this particular case was that the x equaled 2 and the y equaled 1. Okay, so if we wanted to write that as an ordered pair, we would write that the x equals 2, the y equals 1, and that's an ordered pair. So that's the one point on the graph where they cross. So these two methods are what we've done so far, and today we're going to go into a third method called elimination. And elimination it's a lot simpler than substitution as far as the number of steps, and it's also kind of a simpler process, obviously, if there's not as much steps. So I'll kind of go through that with you, okay? All right, so if you flip to the next page, go to example 1. This is an example of a system of equations. Now, I'm not really going to worry about the story problem aspect of it right now. I'm just going to look at the steps to solving a system of equation. So the first thing you do in a system is you make sure that they are both in standard form. And these are, you've got an x, a y together on the left, and you've got a number on the right of the equal sign. You also want to make sure that the x's are stacked on top of each other, the y's are on top of each other, and then the equal signs line up, and then the number on the other side lines up. So then you draw a line, and you look at this in 3 separate columns, right? So you've got the column of x's, you've got the column of y's, and then you've got the column over here on the other side of the equal sign. And your equal sign should stay right where it's at, okay? Reduce each column. And when I say reduce, I mean combine like terms. I mean add or subtract, okay? So the way you know whether or not to add or subtract is the signs that are with each variable. So when it's not there, it's a plus. So that's plus 2x and plus 4x. And when you've got 2x plus 4x, that adds up to 6x. Now, when you have plus 1y, you got to remember there's a 1 there. When you've got plus 1y and minus 1y, that's like saying you've got 1 apple and you take away 1 apple. How many apples do you have? Well, you have 0 apples, right? They're gone. 1 apple minus 1 apple is 0. So if you've got 1 minus 1, it's 0. So the y's zero out, or we like to say kind of in lazy terms, they go away, okay? And then when we simplify the green column, the 8 plus 4, it's 12. Well, now, if we wanted to clean this up, and you actually can just do this in one step, you don't have to write this in 2 steps, but I had 6x, my y zeroed out, and I have 12, okay? So now, if I divide by 6, and I divide by 6, I get x equals 2. So you can see that this is a lot less work than substitution, right? In substitution, we had to get one variable, solve for itself, then we had to substitute it in, do a lot of distribution, a lot of combining like terms. It was very lengthy, okay, in the way you have to work them. These are much simpler. Now, we still only have half of our answer, because if you have an x and a y in your original problem, you have to have an answer for x and an answer for y, unless it's a special case, and we'll get into that a little bit later. So right now, we know that x equals 2, so we still need a y. Okay, so we're going to come up here to one of these two equations, and it doesn't matter. I'm going to pick this one. It doesn't really matter which one you pick, so I'm going to rewrite it. 2x plus y equals 8. And now, what do I know? I know that x equals 2, right? And so I'm going to come up here where there's an x, and I'm going to substitute a 2 in for the x, or I'm going to plug in the 2, because I now know it. It's part of my puzzle. So 2 times, now in place of the x, I'm going to put a 2, plus y equals 8. And then you always get rid of the multiplication or the distribution, the parentheses, however you want to think about it. But 2 times 2 is 4. I haven't done anything with the plus y equals 8 yet. And now I want to solve for y. So I'm going to subtract the 4 off of there because I want it off of that side with the y. And I'm left with y equals 4. Okay, so there's my x and there's my y. All right, that is using using elimination to solve the system of equations. Stack them on top of each other, okay, and then eliminate whatever eliminates. Now, this was kind of your most basic example where the way the system was given to us, the plus y and the minus y canceled out right off the bat. We didn't have to do any extra work to get there. But I want to show you, if you'll go to example number 2, okay. Actually, is there a try it? Nope, I was hoping there was a try it for example number 2, but there is not. So let's look at example number 2. So example number 2, look at your columns, okay? Always look at your columns. You've got the x column, you've got the y column, and you've got the number column on the other side of the equation. Now what you need is you need the number to be the same, but the sign to be different. Remember that? That's what we did here, right? We had the number was the same, and I wrote it in there, but it was a 1 and a 1, but the number was the same, and then the sign was different. It was a plus and a minus, right? So the number was the same, and the sign was different. So if you look at this example, okay, you've got the number the same, because really it is a 1 and a 1, right? We don't usually write it there, but we need to know it's there. But they're both positive, and they don't eliminate if they're both positive, because if I try to draw my line and just add my columns, I'd get 1x plus 1x is 2x. They wouldn't go away. And then over here, I'd get 1y plus 5y is 6y. So the y's wouldn't go away. So the x's don't go away, the y's don't go away. So this is not working as it is right now. However, I've got some tools in my tool chest here that I can use, and one of those is using multiplication to force one of those to line up right. So if I've got this 1x and this 1x that are good, but I need one of them to be negative, I can pick, and it doesn't matter which one, I can pick one of these equations to multiply a -1 into the equation. And remember, when you multiply something in an equation, you have to multiply it to all 3 terms, right? You have to distribute that -1 to everything, or else you've changed the problem. So now, -1 times x is -x, and -1, I'm right here, -1 times y is -1y, or just -y, it doesn't matter if you put the 1 or not. And then equal sign, and then -1 times 20 is -20. Now, I didn't do anything to this bottom equation, so I'm just going to rewrite it. It was x plus 5y equals 68. All right, now it's set up, and it looks just like the first example we did. Look at your columns, right? You've got the x column, you've got the y column, and you've got the number column, and we are going to simplify each column one at a time. So negative x and positive x, they cancel out, or they zero out, they go away. If you want to put a 0 here, you can. It doesn't really matter. Then you look at the purple column, and you've got negative 1 plus 5, which is negative 4y, equals negative 20 plus 68 is positive 48. When the signs are different, you subtract the two numbers and always take the sign of the bigger. So 5 minus 1 is, that was supposed to be a positive. Sorry, guys. Negative 1 plus 5 is positive 4y, and negative 20 plus 68 is positive 48. Now we need to get the y by itself. This 0 just goes away. It doesn't really matter. You don't need it. We're going to divide by 4 and divide by 4, and we get y equals 12. Now that's half our answer, right? We know that y equals 12, but we need to find the other half of the answer, so we have to go to one of the equations, and the book chose this one. Oops. The book chose this one. That's this equation right here, this original x plus y equals 20, and that's fine. It doesn't matter which one you pick. So we're going to use that, and we know that the y is 12, right? We got that from right here. So we can plug that 12 in place for the y, and we get x plus 12 equals 20, and then we minus 12 and minus 12, and that's how we get x equals 8. And that is our solution. Y equals 12 and x equals 8. Okay, so let's go a step further here, and let's look at when you have to do a little bit more than multiplying by a negative 1. All right, so let's take this example, and actually I think, let's look at the try it. Yeah, we'll do this one. We'll just do the try it so we don't have to mess with all those story problem examples. Okay, so let's look at this one as just a basic system of equation that we want to solve. So the first thing we do is we look at our columns. We've got our x column, we've got our y column, and we have our number column, all right? Now, as it stands right now, the x's, you've got a 3x and a 1x. They don't eliminate. You've got a negative 5y and a positive 2y. They don't eliminate. So I've got to force something to eliminate. So I need to use my knowledge of multiplication, and I need to multiply either the x or the y by whatever it takes to make it or force it to eliminate. So if you look at your x's, your top x is 3x. If I multiply the bottom x by 3, that would give me another 3x. But I need it to be negative 3x, so I would want to multiply it by negative 3x, because now, if I do that, if I multiply that x by negative 3, I get a positive 3x and a negative 3x, and that gives me what I want. But I have to remember the rules of math, and that is if I do it to 1, I have to do it to all 3. Okay, so the top equation, I'm not messing with at all, so I'm just going to rewrite it just as it is. 3x minus 5y equals negative 9. Okay, I didn't change anything. The bottom equation, I multiplied everything by a negative 3. That forced that bottom x to be negative 3x, which is great. That's what I wanted. Negative 3 times 2y is negative 6y, and negative 3 times 8 is negative 24. Now what do I have? Look at your columns, okay? And I won't do this highlighting every time, but just at the beginning here, look at your columns. We've got our blue column, we've got our purple column, and we have our green column, right? Our x, our y, and our number. Now again, remember your 0 or your equal sign just stays your equal sign, okay? Now, exactly what we needed happened. We have 3x and negative 3x that cancel out because 3 minus 3 is 0. We have negative 5y and negative 6y, which gives us negative 11y. And we have negative 9 and negative 24, which is negative 33. Remember, negative, negative goes deeper negative. And then we want to divide by a negative 11 on both sides, and we get that y equals negative 33 divided by negative 11 is positive 3. So there's half my answer, okay? Now, I need to take one of the other equations, and I am personally going to choose this one right here. X plus 2y equals 8, my original little guy, okay? And the reason I like him is because he already has the x by itself. So x plus 2y equals 8, okay? That's this equation right here. That's the original equation before I multiplied by negative 3 through it. Now, I know that y right here is a 3. So where there's a y, I'm going to plug in a 3. So that gives me x plus 2 times 3 equals 8. And so x, 2 times 3 is positive 6, so plus 6 equals 8. I'm going to minus 6 and minus 6, and I get x equals 2, and there's the other half of my answer. Okay? All right, so that is an example of when you don't have to, example number 1 was when you didn't have to do any extra work and 1 already eliminated. Example number 2, all you had to do was multiply by a -1 to change the sign of one of them. When your numbers already match up and you just need to change the sign. Example number 3, which is the one we just did, we had to multiply a -3 through one of the equations to force that positive 3x and negative 3x. I want to do one more example with you. And it is like, let's see here, you'll probably want to use page 290, and you can just use any of the open space here. I've got it down here on a extra sheet, but you can just use that page 290. So on page 290, I want you to use one of those empty spaces to write down this equation. Pause the video if you need to, get the equation written down, and then we'll start talking through it. So the first thing you look at is your columns, okay? So if I look at, and I kind of already have everything highlighted, so I'm going to rewrite this so I can get rid of those highlights. So negative 4x minus 10y equals 24, and 5x minus 8y equals 11. Okay, so I have these two equations, and I need to start deciding what I want to make go away. So always look for the easiest route first. Is there anything that just right away goes away? Look at your columns. Okay, look at your columns. -4 and positive 5, they do not go away on their own. -10 and -8, they do not go away on their own. And then 20, oh, that doesn't matter. We don't need to worry about that right now. Okay, so nothing goes away on its own yet. So then I need to look and see, can I just multiply a negative through something? Well, if I just change the sign of the -4, it's a positive 4, still doesn't go away. If I change the sign of the -10 or the -8, they still don't match up. The numbers still aren't the same. So I need to see if I can just multiply. Could I multiply anything in this top row to make a 4 equal a 5? And there's no whole number I can multiply 4 by to make it a 5, so that doesn't work. In the bottom, could I multiply that 8 by anything to make it a 10? I can't. There's no number. There's no whole number that makes an 8 a 10. So that makes this a double multiplication problem. So when you have that, you put parentheses around both. Remember, you need your signs to be different. And I already have a -4 and a positive sign, a positive 5. So I'm going to use those as the ones I'm going to eliminate. And so I'm going to take my x's, and I'm going to put this 5 up here. And then I'm going to take this 4 and I'm going to write it down here. So I'm going to crisscross the coefficients. So I'm going to put a 5 here and a 4 here. And the reason I do that is because when I distribute, when I take 5 times -4x, I get -20x. When I take 5 times -10y, I get -50y. And when I take 5 times 24, I get 120. Okay, that's the top equation rewritten with my little math work here. Now across the bottom, I'm going to take 4 times 5x, which is positive 20x. I'm going to take 4 times -8y, which is -32y. You can see how really watching your signs here is going to matter. A positive times a negative is a negative. And then a positive 4 times a positive 11 is a positive 44. Now I'm ready to draw my line. If I did it right, okay, my x's should eliminate. Okay, if I did it right, because that was what my goal was, I should have a -20 and a positive 20, and that's exactly what I have. -20x and positive 20x cancel out. They're gone. Then I go to the y's right here. I'm going to reduce my y's. I've got -50y minus 32y, which is -82y. Remember, negative goes deeper negative. Then I've got to do this side. I've got 120 plus 44, which is 164. Now I've got to divide by a -82 and divide by a -82, and I get y equals -2. All right, again, that's half my answer. Okay, so I need to, if I have an x and a y, my answer has to have an x and a y. So now I'm going to take one of these two equations, and it doesn't matter which one. I'll take the top one because it really doesn't matter. -4x minus 10y equals 24. Okay, that's that top equation. Now, what do I know? I now know that y is negative 2. So where there's a y, I'm going to put parentheses, and I'm going to substitute a negative 2 in there. And when I do that, I get negative 4x minus 10 times negative 2 equals 24. Negative 4x, and negative 10 times a negative 2 is a positive 20. I'm going to subtract 20 from both sides because I want to get x by itself now. And when I do that, I get negative 4x equals 4. Again, I still want to get x by itself. It's attached by multiplication, so I do division. I divide by that negative 4. That reduces to 1 or goes away, and I get x equals negative 1, and that's the other half of my answer. So 2 variables in the problem, you need to have an x and a y as the answer. Now, the one difference as far as what your possible outcomes could be, sometimes you're going to get an x and a y, like here. Sometimes, and I'm just going to go through this real quick, okay? Possible outcomes for systems, okay? We've talked about this already. This was our jump start last week. Number 1 is one solution. That's an example of the problem we just did, right? This is a one solution because we got an x, we got a y. There's one x and one y that work. And if we wanted to write it as an ordered pair, we could write negative 1, negative 2, and that would be our solution, okay? Other outcomes is no solution. And I'm going to tell you an example of that. An example of no solution would be if you have something like negative 3x minus 2y equals 8, and you've got positive 3x plus 2y equals 2. All right, that's a system. Okay, I'm going to draw my line, and I'm going to reduce my columns, this column, then this column, then this column. Okay, so when I reduce the blue column, the x's, negative 3 plus 3 zeroes out. When I reduce the y's, negative 2 plus 2 also zeroes out. And 8 plus 2 is 10. So I end up with 0 equals 10. Does 0 equal 10? No, it does not. So this is a special case. No solution is a special case where your x's and your y's both zero out, and what you're left with is an untrue statement. Now, an example of infinitely many, which is the third possible outcome when you're solving a system of equations. An example of infinitely many would be, let me just make up an equation here, I've got to write a little bit smaller, would be, okay, let's do the kind of make it sort of similar. And we will.
Fire drill. I'm not going to set off the alarm.
Okay.
The phone, the fire drill will begin.
So we have kind of similar to this one, but when you reduce the x's, you get 0. When you reduce the y's, you get 0, right? Negative 3 and positive 3 zeros out. Negative 2, positive 2 zeros out. But look over here, you have 8 minus 8, which is also 0. So you end up with 0 equals 0. Notice in both cases, the x and the y zero out, but in the no solution case, or in the no solution one, this was a no. 0 does not equal 10, and 0 will never equal 10. In the infinitely many, you've got 0 equals 0. Well, for infinity, 0 will always equal 0. So, if you have and remember I said both of these are special cases, okay? Both of these are special cases. To have a special case, both the x and the y, and I use x and y, I don't care what variables it is. It could be b and l, it could be p and q, whatever the two variables are, it doesn't matter. But both variables zero out, okay? Both variables zero out. And when that happens, you have to ask yourself, is it false, like no solution, or is it true, and that means it's infinitely many? Okay, that pretty much wraps up system of equations by elimination. Your homework, if you look on Canvas for Monday, was the workbook. It was these pages right here. There we go. It was pages 291 and 292, and it was 7, 8, 11, and 14. And then your homework for Tuesday is the Khan Academies that are linked on Canvas under Tuesday's date. And if you have any questions, shoot me an email.